Okay, question 18. Looks like a quadratic, a U-shaped graph there. Don't know the equation, but what we do know is the minimum point at the bottom is -2, -1. And what we're looking to do is find out where that point goes if, rather than drawing that graph f of x, we were to draw the graph y equals f of x minus 5. Now, using what we know in the transformation of graphs section in the textbook, f of x minus 5 is a translation of 5 to the right. So this point here would move 5 to the right over here somewhere, so the -1 y value would stay the same, but adding on 5 to the -2 gives us the value of 3. So that minimum point, if we were to draw that new graph, f of x minus 5 shifts that minimum point to 3 minus 1. For the second transformation, which is y equals a half f of x, again using what we know about transformation of graphs, this is a stretch of scale factor of a half in the y direction. So it's like you're pulling this graph up and pulling this graph down, but with a scale factor of a half. So actually it's more like a squeeze. So it would squeeze towards the x-axis. So this -1 value would move towards the x-axis a bit closer. Scale factor a half, it would be halved. Doesn't affect how far across you go, so it would still be -2. Answer then is -2 minus a half. Okay, so the second part of the question, or the third part, is the graph, and we've got given the formula here is a sin brackets x minus b close brackets plus c. Just before we look at the graph, breaking down what those letters do, again using our transformation of graphs knowledge, is that the C is a translation in the y direction, so it moves the graph up and down. The B moves the graph left and right. This is minus b in here, so just be careful with the transformation of graphs when you do anything with x, because it is the opposite of what you think it's going to do, the opposite direction, but we'll come to that in a moment. And a is a stretch of scale factor a. Okay, so just looking at this curve now, look, the difference between the top and bottom of this curve, it goes up to 3 and down to -1. Normally the sin curve goes up to 1 and down to -1, so it would have a difference of 2 between the top and the bottom. Ours has a difference of 4, so that distance has been doubled. That's what our stretch is in the y direction. It has doubled the distance between the top and the bottom, so scale factor 2 for a. Okay, then really what we need to do is concentrate on where the origin point ends up. Look, normally the 0, 0 point halfway between the top and the bottom on the sin curve would be just here at 0, 0, and that point now is over there. It has moved 90 to the right, which is our x translation 90. I know that's moving in the plus direction, but in the in the transformation of graphs, a plus b would be a move to the left, and a minus b would be a move to the right. So our b value is 90, and it has gone up by 1. So the translation in the y direction is 1. Gives us a final answer of stretch scale factor 2, 90 to the right, and 1 up.